Hi everyone. Today I want to share some fascinating and amazing facts about one of the most intriguing celestial objects, our planet Earth. You don't need to travel far into space to find something as interesting and beautiful. Earth has vast oceans of water, an oxygen-rich atmosphere, and a powerful magnetic field. Most importantly, it's the only known place in the universe where life exists, our home. Despite living here, there's still so much we don't know about our planet. What makes this small dot in the vast cosmos so special? And what have we learned about it so far? You might have heard that Earth is described as pear-shaped or egg-shaped. This can be a bit misleading because, in reality, Earth isn't a perfect sphere. It's slightly wider at the equator than at the poles by about 45 kilometers, due to the planet's rotation, which causes a bulge at the equator. The farthest point from the center of the Earth is not the summit of Mount Everest, but the peak of the Chimborazo volcano in Ecuador. The average diameter of Earth is about 12,742 kilometers. Since ancient times, Earth has been at the center of attention for scientists and philosophers. They asked questions like, does the universe revolve around us? Do we revolve around the sun? Is Earth flat around? The idea of a round Earth dates back to the 6th century BC, but it was in 240 BC when Eratosthenes calculated its circumference. He used observations of the angles of shadows in different cities in Egypt during the summer solstice and calculated the Earth's circumference with an accuracy of 5–10%. In the 16th century, thanks to Nicholas Copernicus, Johannes Kepler, and Galileo Galilei, we learned that the sun is the center of our solar system, not the Earth. Today we know that Earth is the third planet from the sun and one of the 4 terrestrial planets. It orbits the sun at an average distance of 150 million kilometers, which takes 1 year. Interestingly, our way of measuring time isn't as precise as it might seem. For example, Earth orbits the sun in 365.25 days. So every 4 years we have a leap year. Did you know that the month should correspond to the moon's orbit around Earth? The words month and moon are closely related, but actually the moon takes 27.3 days to orbit Earth once, and our calendars don't account for this. Imagine how difficult it would be to fit months of such length into a 365-day year without extra days. That's why those who created calendars throughout history mostly didn't try to do so. And just as our years aren't exact, neither are our days exactly 24 hours long. A sidereal day on Earth, or the time it takes for Earth to rotate 360 degrees relative to the fixed stars, is at about 23 hours and 56 minutes. So where do those 4 minutes go each day? In reality, we don't use the sidereal day to measure time. We use the solar day, the moment when the sun makes a complete circuit in our sky, and is in the same place as the previous day. How does the solar day differ from the sidereal day? The thing is, Earth isn't stationary, and as it orbits the sun it moves slightly forward compared to the previous day, changing angles relative to the sun. It takes an extra 4 minutes for the sun to be directly overhead again, giving us the exact 24 hours in a day. But things get even more complicated if you delve into the topic. Due to Earth's slightly elliptical orbit and axial tilt, true solar days can vary by up to 30 seconds throughout the year. To balance this, we use mean solar days, which average out all these variations over the year. Moreover, due to tidal friction from the moon, which slows down Earth's rotation, our days have lengthened by about 2 milliseconds per century. While this may not seem significant to us, 500 million years ago, days were less than 22 hours long, and there were about 400 days in a year. This shows that keeping track of time is much more complex than it appears. The Earth's rotation can be beautifully observed from the ground through time lapses at night, where the fixed field of stars moves before our eyes. Earth's orbit around the sun, combined with its axial tilt, means that the sun's position at the same time each day varies throughout the year. This can be seen in an analemma, a photograph made from composite images taken throughout the year. As you can see, the sun traces a figure 8 pattern over the year. The north-south movement is related to Earth's axial tilt, which you surely notice with the changing seasons when the sun is higher in the sky during summer than in winter. The east-west variation is due to the eccentricity of Earth's orbit, combined with the so-called equation of time, which, very simplified, we looked at regarding variations in the sidereal day, the true solar day, and the mean solar day. This graphical representation shows the combined effects of the equation of time, Earth's axial tilt, and its orbital eccentricity. While we haven't done this for other planets yet, if you created an analemma on another planet, each planetary analemma would look different. Here's a simulation of how it would look on other planets. The differences are due to variations in the days, orbits, and axial tilts of the planets. Did you know that Earth's axial tilt is approximately 23.5 to the plane of the solar system? This axial tilt is what gives us our diverse seasons. Interestingly, the temperature changes between seasons are more due to the amount of sunlight hitting a specific point on Earth than the proximity to the sun. Being a few thousand kilometers closer to the sun doesn't make much difference when the distance between Earth and the sun is 150 million kilometers. If it were significant, we'd notice that perihelion, or the closest point of Earth's orbit to the sun, has a substantial impact, as at perihelion we are 5 million kilometers closer to the sun than at aphelion, the farthest point of the orbit. Do you know when Earth last reached perihelion? It happened in January. In reality, the main reason for the temperature difference between seasons is the area of surface receiving sunlight. In summer, when the sun is high overhead, a point on Earth receives much more concentrated sunlight. In winter, when the sun is low on the horizon, the same sunlight spreads over a larger area. Additionally, in summer, days are longer, allowing the sunlight to heat the Earth's surface for a longer time compared to winter. When sunlight hits the ground or the ocean, heat is released into the atmosphere. Earth's atmosphere is quite dense and compact. Although its total mass is small compared to places like Venus and Titan, it consists mostly of 78% nitrogen, 21% oxygen, and 1% argon, with trace amounts of other gases such as carbon dioxide. Water vapor is also present in the atmosphere. Its amount can vary from 0.01% to 4%, but on average it is 1%. This water vapor forms clouds in the atmosphere. Ozone is also present in a special layer of the atmosphere called the ozone layer. This ozone absorbs much of the harmful ultraviolet radiation from the sun, protecting life on land and allowing it to thrive. Without this layer, Earth would be a dangerous place for life as we know it. The atmosphere performs many essential functions for life. It provides us with useful gases such as oxygen and carbon dioxide, causes small meteors to burn up before they reach the surface, and even regulates temperatures across the planet. Without an atmosphere to trap some of the heat from the sun, Earth would be much colder, 18 degrees C on average compared to the current 15 degrees C. The atmosphere also manages one of the most crucial systems for us, the water cycle. When the sun heats the Earth and its oceans, water on the surface evaporates and rises. This water vapor then cools and condenses on dust particles in the air, forming clouds. In this form, water particles can travel long distances before falling as rain. The water is then transported back to the oceans via rivers, completing the cycle. Traveling water not only erodes the surface, but is also vital for all living organisms, from plants to bacteria and animals. Another important system of Earth is the hydrosphere, mainly its oceans. The existence of life on land largely depends on Earth's oceans. The oceans cover a vast area, making up 1/4400 of Earth's total mass. To understand the scale of the oceans, imagine that if Earth's surface were completely smooth, the entire planet would be covered by an ocean nearly 3 kilometers deep. Fortunately for us, the surface of the Earth is highly diverse. This is partly due to a unique feature of our planet, plate tectonics. The Earth's crust is relatively thin, with a hot and active mantle layer beneath it. Sometimes we see the consequences of this mantle movement when crustal plates collide, crash, and separate, forming volcanoes, earthquakes, mountains, and ocean trenches. Looking at a three-dimensional map of Earth's relief, you can clearly see mountain ranges and deep depressions created by plate tectonics. It might seem that plate tectonics is dangerous for life on Earth. Indeed, it can be hazardous for people in certain places at certain times. But this process of constant surface renewal makes Earth fertile and fresh. Beneath the mantle lies the planet's core, which is mostly composed of iron and nickel. Earth is the densest planet in the solar system, with a density of 5.5 GCM3, mainly due to its core. The core is quite large compared to other planets. The outer core has a diameter of about 5,000 kmu, and the inner core is believed to be solid with an extreme pressure of 360 GPa and temperatures up to 6,000 degrees. The core is also the source of Earth's magnetic field. As the core moves, kinetic energy is converted into electrical energy, creating a vast magnetic field around the planet, similar to the magnetic field around a giant dipole magnet. This magnetic field protects life on the surface by deflecting the solar wind, streams of high-energy particles from the sun, around the planet and toward its poles. Without this, solar storms would regularly bombard Earth with deadly charged particles that would destroy our DNA and strip away the atmosphere. But thanks to the magnetic field, we can admire the beautiful auroras, where particles interact with the atmosphere. The most common color of the aurora on Earth is green, due to the interaction of the solar wind with atomic oxygen. There is another very unique aspect of Earth that I want to mention: its moon. While many other planets have moons, Earth has the largest moon relative to the size of the planet. This allows us to observe a true spectacle in the sky, a massive celestial object that is so close we can see details of its surface with the naked eye. But having such a large object nearby also has a real impact on our planet. The moon influences our ocean tides thanks to its gravity, which pulls on the water in our oceans, creating tidal waves as the planet rotates. Interestingly, tidal forces affect not only the oceans, but also the Earth's crust, although this effect is less noticeable. However, these forces might be one of the reasons for the active plate tectonics on Earth. After conducting research for this video, I am struck by how many factors had to come together for life to originate and evolve on our planet. Thanks to all these conditions, we have become part of a species that numbers over 8 billion people, a species with intelligence that allows us to question our existence and find our place in the universe. The beauty of our planet is also awe-inspiring. Thanks to space exploration, we can see our home in ways people only dreamed of 100 years ago. Is there anything else in space as beautiful and hospitable as our planet? Write in the comments what you think. Thank you for watching. This was the last video in our series about the planets of the solar system, and it has been an unforgettable journey. I hope you enjoyed this series and felt the same excitement I feel when looking at the solar system. Don't worry, even though this series is over, there is still much more to come. The universe is an infinitely vast place, and there is always something to discover. Perhaps one day we will find a place as exciting and incredible as the planet where we began our journey.